Welcome to Unit 7, Part 3 video on similar triangles. Now, just like proving triangles congruent, there are certain shortcuts to prove triangles similar. They are not the same, but they're still shortcuts. The first one is what we call angle-angle similarity. If we say two angles of one triangle are congruent to the corresponding two angles of another triangle, then the triangles are similar. All right, and it's abbreviated AA with the similarity sign. So it says here, determine whether the triangles are similar. Well, one thing you got to keep in mind is that triangles add up to 180. So 180 minus 52 plus 42. 180 minus 94, which means that that's 86 degrees up here. So notice, since that's 86, now we have two angles of one triangle congruent to two angles of the other. So that means triangle ABC would be similar to triangle FGH, and it's by angle-angle similarity. Here in number 28, parallel lines mean you have alternate interior angles that are congruent. Those ones and that one there. So you could say triangle PQX is similar to triangle MNX by angle-angle similarity. And the last one, 58 plus 42 is 100. So then this is 80. And notice now you have two angles of one triangle congruent to two angles of the other. So triangle ABC is similar to triangle EDF, and that's angle-angle similarity. All right, the two other similarity reasons, one of them is side-side-side similarity, and that doesn't mean the sides are equal. That means the sides are proportional. So if the three sides of one triangle are proportional to the three corresponding sides of the other, then the two triangles are similar by side-side-side. And then there's also what's called side-angle-side similarity. If the two corresponding sides are proportional and the angle between them is congruent, then that's what's called side-angle-side similarity. So we'll look at these pictures here. So notice there's a couple things that you could look at here. Number one, for the triangles, like what's the ratio of 9 to 6? And that's 3 to 2. And then you could say 6 to 4 is also 3 to 2. And 7.5 to 5 is also 3 to 2. So therefore, all the ratios are 3 to 2. So we could say triangle ABC is similar to triangle DEC by side-side-side similarity, because all three corresponding sides are proportional. Here you have two triangles. You have the smaller one right here, and you have the whole one. Now understand the side here in the whole one's 25, and the side here in the whole one's 30. So you have to ask yourself, is 10 over 25, which that scale factor would be 2/5, is that equal to 12 over 30, which is also 2/5? And then notice angle M is the same in both of them. So you could say triangle MNP is similar to triangle MRS by side-angle-side similarity. And then here in the last one, you have parallel lines again, so you have alternate interior angles. So you have triangle ZWV is similar to triangle XYV, and that's by angle-angle similarity. All right, so the next question says, given that RS is parallel to TU, RS is equal to 4, RQ is x plus 3, QT is 2x plus 10, and UT is 10. Are the two triangles similar? Well, the answer to that is yes, because you could say angle-angle similarity here because of the parallel lines. So yes, triangle TUQ would be similar to triangle RSQ by angle-angle similarity. The scale factor, well, 4 over 10 is equal to 2/5. So that's the scale factor. And then to find RQ, well, we have to find x. So 2/5 is equal to x plus 3 over 2x plus 10. So 2 times 2x plus 10 is equal to 5 times x plus 3. So you distribute, subtract, so you get 5 equals x. So now to find RQ is 5 plus 3, which is 8. And TQ is 2 times 5 plus 10, which is 20. All right, so go ahead and try the next one, and then it's similar, and then I'll show you the answers. All right, so the triangles are similar by angle-angle similarity because the parallel lines give you congruent alternate angles. Interior angles, sorry. And then the scale factor, if you go 38.5 over 11, is 7 over 2. If you need to use your calculator, go 38.5 divided by 11. And if you want to change that to a fraction, you go to math fraction, hit enter, and that gives you the 7 over 2 part. Like that. So your calculator can do the reducing fractions for you. And then you take the 7 over 2 and set it equal to 3x plus 8 over x plus 2 to find x. To find AE, which is the whole thing, you can either put the x in separately and just add it together like I did, and you get 18. All right, 35. On her trip along the East Coast, Jenny stops to look at the tallest lighthouse in the U.S. located at Cape Hatteras, North Carolina. At this particular time of day, Jenny measures the shadow to be 1 foot 6 inches in length, and the length of the shadow of the lighthouse to be 53 feet 6 inches. Jenny knows that her height is 5 feet 6 inches. What is the height of Cape Hatteras Lighthouse? So you set up a proportion. Now 1 foot 6 inches is 1.5 feet over 5.5 feet equals, because 6 inches is half a foot, equals 53.5 over x. So you cross multiply, and 53.5 times 5.5 gives you 294.5 divided by 1.5, and you get x is equal to 196.16 blah 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 blah. So it's about 196.2 feet. All right, so the next one, Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured the shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow. It was 242 feet at the same time. What is the height of the Sears Tower? So he used a 12-foot light pole and the shadow was 2 feet. Then he measured the length of the Sears Tower shadow. It was 240 feet at 2 feet at the same time. So what is the height of the Sears Tower? So it's a 12-foot light pole with a 2-foot shadow. And it wants to know how tall is the Sears Tower with a 242-foot shadow. So if we cross multiply, so 242 times 12, and then divide by 2, you get 1,452 feet. That's how tall the Sears Tower is. All right, find the width of the river here. Well, you have two similar triangles because you have two right angles and then the alternate interior angles here. So angle, angle, similarity. The vertical angles. So 24 over 30 is the scale factor, which reduces to 4/5. So to find the width of the river here, you take 4/5 equals x over 28. So you get 5x equals 4 times 28, and then you divide by 5. And you get that the width of the river is approximately 22.4 meters. All right, so that concludes part 3 video. Part 4 coming up soon.